Alaikum wa rahmatullahi wa barakatuh. My name is Wissam Adil Al-Satli, Lab 3 Operating Systems, ID 1085899. So in this laboratory experiment, I implemented different multi-threading techniques using the C programming language. The purpose of this lab is to understand how multi-threading improves system performance and reduces execution time when the processing large workloads. So for this experiment, we used a large text file that was analyzed using three different implementations, fold 1, fold 2, and fold 3. The program calculated the total number of lines, words, vowels, uppercase letters, and the largest word in the file. I used OpenMP for implicit threading and pthreads for explicit threading. The execution time and the CPU utilization of each implementation were compared in order to evaluate the impact of multi-threading on the program performance. And now I will run the first command for fold 1. First, we will just use the command to show the files and ls to display which files are inside our lab file. So we will do that. This is where my file is stored, and now I will display what is inside ls. So now I will use the command for fold 1. Okay, so now I will do for fold 1, of course with my ID inside. 1 second. Okay, so let's run it. So as you can see, this is the fold 1 where we used both implicit and explicit multi-threading techniques that were implemented. OpenMP was used for implicit threading and pthreads was used for explicit threading. First, I compiled the program with GCC using both MP and pthread libraries enabled. And after running the program, as you can see, the output shows the parent thread ID, the OpenMP thread count, explicit pthread thread ID, and the final processing results. OpenMP automatically utilized the 16 threads on my laptop that I'm using based on the available CPU resources, and the OpenMP section handled counting the total number of lines, words, vowels, and concurrently, while the pthread section divided the file into 4 sections to calculate the longest word and uppercase letters because multiple threads processed the workload simultaneously. Fold 1 achieved a much faster execution time compared to sequential execution, which we'll see in fold 3. So the CPU usage also showed that multiple CPU cores were utilized during execution. Next, we will run for fold 2. Okay. So as you can see, it's around 0.2 execution, which I will talk about now. So for fold 2, only implicit multi-threading using OpenMP was implemented, unlike fold 1. Pthreads were not used in this implementation. OpenMP automatically divided the large text file among the available threads and processed multiple sections of the file concurrently. After compiling and running the program, the output displays, as you can see, the number of threads used, total number of lines, words, vowels, uppercase letters, the longest word, and the execution time. According to my results, fold 2 achieved the fastest execution time among all implementations among fold 1 and fold 3, which is around 0.2. So I got 0.2, now it's 0.26, around that range. This demonstrates the efficiency of OpenMP in parallel processing and workload distribution. The CPU utilization also confirms that several CPU cores were active during execution, which improved overall system performance. Next, let us go ahead and run for fold 3. So for fold 3, as you can see, implemented sequential processing without using any multi-threading techniques such as OpenMP pthreads. In this implementation, the large text file was processed step by step using a single execution flow on one CPU core. After compiling and running the program, as you can see, the output has displayed the same processing results, including the total number of lines, words, vowels, uppercase letters, and the longest word. However, because all operations were executed sequentially, the execution time was significantly higher compared to fold 1 and 2. So in my experiment, fold 3, around 2.2 to 2.35 seconds execution time to complete execution. The CPU usage also showed that many one CPU core was utilized during processing. This demonstrates that sequential execution is less efficient for handling large workloads compared to multi-threaded implementations. As a conclusion, The laboratory experiment demonstrated the importance of multi-threading and improving system performance and reducing execution time. Fold 1 and Fold 2 both achieved better performance compared to Fold 3 because they used parallel processing techniques. Fold 2 achieved the fastest execution time due to efficient workload distribution using OpenMP. However, this experiment provided a better understanding of explicit threading, CPU utilization, workload distribution, and the advantages of parallel processing in operating systems. Thank you.